To start off, we're going to be talking about in-place families and how to turn them into component families. Sometimes a model can get filled with these in-place families that people make on the spot because they need the model project's, local geometry to help dictate the size and shape of what they're making. But they don't realize that as you copy these around a building, every instance is its own unique thing, and it really bogs down a file. So it's better to use a real component family. Luckily, you can turn one into it. So we're just making a in-place family here, just a simple extrusion for this example. And once we've made the extrusion, we can go, and while we're still in this edit mode for the in-place family, we're staying in here. We can select the geometry, go down through the project browser, and go model, group, create group. Okay. Give it a name, and that's going to be the name that your family is going to have when you're done with this. All right, so at this point, yes, go down to your project browser, look for the model group, right-click, and hit Save Group. This will allow you to save the family outside of the project as an RFA, which is a Revit family file extension. I'm just closing out of the in-place family I made, which eliminates it from my project, and now I can go and open the family that I made. So I navigate to the desktop where I put it, scroll down, and there is my family. See it right there, and here we go. So we can take this, change the family category. Let's make it, specialty equipment. And it's just like any family you'd be making from scratch in the family editor. You can change the material, add parameters, whatever you want. Now we're going to load it into the project, and we can place it. And unlike in-place families, here, if we edit the family and load it back into the project, it will make the change to every single instance in the project. All right, on to number 2, cutting with voids on load. So most families where you want to cut the surface of the element that you're hosting on either use a hosting family, like a ceiling hosted family or a wall hosted family, or they use a face-based family. The issue with these I've found is twofold. One, it can only cut through the main host family. So if you've got like a plumbing chase that is made of 2 walls and you have a face-based family or a wall-based family, it'll cut the one wall that you've put it in, but it's not going to be able to cut through the other side made from a second wall. Similarly, if you've got a finished floor and a structural floor below, if you have a floor-hosted floor box, it'll only cut through one of those 2 families. Now, if instead you make a regular generic family and you check the work plane based option and the cuts with void when loaded option from the family parameter option menu, you will be able to cut multiple system families, multiple host families with this family that you're creating. And the idea behind this is, what made me think of this one is all of the recessed lights we have in a building. We could have thousands and thousands of them, and every single instance is cutting a hole in a ceiling. And it's just a bunch of additional geometry that isn't really necessary in a building. You may only want to cut the ceilings and those handful of places where you're doing 3D renderings. So I wanted to make a ceiling light that can do this. So what we do is go ahead and take your basic recessed ceiling light and activate this work plane based and cuts with void when loaded options, and hit OK. And you can see if I go to a 3D view that the void is shaped to size perfectly with this recessed light can fixture. Okay, so I am going to load it into a project. and start to place it. And when I go to place it, it gives me this option to place on face up here, there on the top right here. Place on face. So even though it isn't a face-based object or a ceiling hosted object, I am placing these and they are being hosted on the ceiling. So I can come over here, select the ceiling, change the height, and the lights will move with the ceiling. Put that back. And let's say these small handful here, I want to cut the geometry of and be able to see those recesses. It's easy enough to do with the cut geometry tool. There you go. So on the same subject of lighting, we move on to number 3. These lights that we placed in the ceiling, they look, at first glance like they're centered, but placing a light perfectly centered in a ceiling grid is actually really hard to do. It's usually going to be off center. And then you have to go back in and, manually adjust all of the numbers, and it can be really frustrating. So one thing that you can do is go back to the light family. Hold on, let me go and edit this and add reference planes around your light. Okay, top, bottom, left, right. We're just going to set these at 1 foot from center so that we've got a perfect 2x2 grid around here. But you could add distance parameters, length parameters, and have it so that you can adjust to any ceiling grid dimension you want, and still be able to center the lights in there. We're going to take those, make them strong references so they're easy to align to and click on. And I'm just verifying that I've got the right dimensions here. Good. Load this into the project again, overwriting the previous version. And now we can use the Align tool and click on it. And we've got these handy references that make sure that our lights are lined up. Very simple. All right, that takes us to number 4, where we are trying to use a material from a project inside of a family. Now, if anyone's ever tried this, so they'll know you cannot copy an element from a project into a family. And oftentimes, if you don't have a company like custom library of materials, you might have a situation where you've got a material in your project that you've made for that project that you're trying to get into the family, and you don't want to start creating the material from scratch. You just want to get that material in there. So what you can do is create an in-place family. When you create the in-place family, just make a simple extrusion, apply the material to that extrusion, and copy the extrusion still while in the edit mode of the in-place family, and paste it into your new family that you're creating. Because you're in this in-place family, you're in a family environment. So even though you're in a project, you're still in a family environment, and it allows you to copy and paste across from the project to the family, and you get the material. This same process works from moving materials from one family to another family. Number 5, families that can scale. So the most obvious thing to do is plants. We've got tree families that scale because you set heights, but there might be other things like vases or columns. So we're just going to do a little vase here. But what you do is you create a planting family, and you host that planting family in another planting family. And you host that second planting family in the family that you actually want to bring into your project. So if that family is also a planting family, then we've got 3 nested planting families. But if it's, what we're doing here is I'm making like a little vase bowl type thing, that final family will be an entourage family, because that would be the proper family category. So I'm just finishing the revolve here. And we'll see as we finish the shape that I would go into the properties of it, and the built-in height thing I will set to whatever the default height I want for bringing this element into a project. Okay, and I'll save this family vase, and I'm doing underscore sub nest because this is the deepest family into my nesting sequence, so it's a sub nest. All right, so now I'm going to create a new family also of the planting type. All right, here we go. And I am going to take my sub nest and load it into that new family I just made and just place it right at the origin point. I go straight then from there to the type properties of the family and adjust this also to that same default height. I can't tell you why this works, but it does. All right, so now I'm saving this family as vase underscore nest. So this is going to be one nesting deep, and we've got the other one that is a nesting of this one. So, all right, now final step is we're going to create one more family. This is the one that's going to be the one that goes into the project. And so here I'm doing entourage, and I'm getting my vase underscore nest, and I'm loading it into this new family. And once again, putting it in the center point. All right, so this time I'm editing the family type that I just selected, that I just nested in. And that height there, I am linking the parameter to the height parameter of the host family. So the height parameter of the entourage family, which this just blew up because it was set to 0. So it's not very happy. But if I change this back to our 2'6", it will resume its proper size and shape. Okay. So I'm loading this into a project. Oh, forgot to save. Yep. We'll just save this as simple vase. Okay. And now I can load it into the project. And let's see here. I'm going to go to a 3D view so we can see this more clearly. Place a few of them. Oh, it looks like I am in the worm's eye view still from the lighting example. All right, place a few of them here. Now we can select one, edit, and duplicate the type. I'll just call this 1 foot because that's the height we're going to use for this one, 1 foot. And here we have a family that just by adjusting the height scales the entire family. Okay, so it's a little confusing, a little complex, but it's also super simple. You're just taking a few of these planting families, nesting them in each other, and putting around. On to number 6, moving complex geometry. Now you can set up a complex geometry so it flexes really well in place, but as soon as you try to move it, it all breaks and it all deletes itself, and it just makes you sad. Okay, being able to flex it doesn't mean you can move it. So what you want to do is copy that content, that complex geometry content, and paste it into a separate family. Okay, you're going to keep it there where nothing can affect it, nothing is going to impact the geometry, and you can load that right back into your main family. Plop it in, and we'll look in a front view because it's not going to be at the right elevation when we put it in. It'll be down at the ground level there. Yeah. So we want to use the align tool to pop it back in to where we want it and lock that. Okay, so we locked that in place. Now when we move the reference plane, our complex geometry moves along with the rest of the family really easily. And we're going to be able to path parameters from the nested family straight on through to the main family. So from the project, you can impact things that are deep in your nested value. So here in my host family, I can change the color of the fixture, and it will change the color in the nest. Everybody's happy. Everything's working smoothly. All right, number 7, making a type catalog. Anybody who's brought in a beam into their project has seen a type catalog before. This is what's on the right here. You never want to bring in every single type of beam into a project. You usually just want like 4 or 5 of them. So it allows you to pick the ones you want and only bring those in, so you're not cluttering up your project. This is also applicable to things like cabinetry, windows, diffusers, drains, and more. You may have a simple shell family that looks and can be stretched and pulled in different ways with all these different configurations, but in a project you only want a handful of them. So how you do it: you set up your geometry, your parameters, everything for your base family as you would normally, but you don't make any family types. Okay, you leave this top part gray, and once everything's right, you name the family, and you go and you export the family types. And you'll see that it's creating a txt file, a text file named the same as your family. You can go and edit this in Notepad, but I would recommend opening it in Excel. You're going to have to click on a few buttons to get it to come in right, but it'll be a lot easier to edit. So you're changing it to all types, selecting the txt file, and hitting open. So it recognizes something's up with this. You're saying it's a delimited file, it has data headers, and now we'll go to the next screen and we'll say that it's comma delimited. That's the version, comma delimited file. Go ahead and hit finish. And here we go. It's just a series of columns with things filled in. We'll clear out the default example one and fill it in with the versions that you want. Your family name, type names, the parameters, and it's all filled in, and then you save it out. Okay, you save it out as a CSV file, comma delimited file. That'll get it formatted back the way it needs to be as a text file, but it's not a text file yet. You have to select that CSV file, edit it, and get rid of the CSV and replace it back with TXT. Now it's a text file again, and they have to be in the same spot with the same name. Okay, that's really important. Same spot, same name. Now when you load it in, go back down, load the file, hit open, it pops open this browser that allows me to pick the specific family types that I need for my project. There we go. All right, on to 8, swapping out parts. Once again, the answer is nesting. So we're going back to that pendant family, selecting the head and giving that this label, adding a parameter. Call it pendant selection. Okay, so we're gonna put this under constraints, and now we have some other pendant heads that we could load in to the family, and we'll be able to easily swap them out. Now this may seem a little odd. Why would we have these 3 different pendants all be one? Well, it makes browsing through your project a lot easier when you just know, okay, here's all my pendants in the project, they're all right there. But more likely it's going to be things you do like hardware on doors. If you've got a door family, you don't want a different door family for every hardware option you might have. You just want to be able to swap out the hardware as a separate parameter. Or if you're actually modeling the fixtures in a sink, those sorts of things, you could do this just as easily. So we load this into a project after we've assigned the different configurations for the different types, and we can put it in, place our pendant, and now when we select it within this one family, we can just pick, and it completely changed the configuration. And this isn't about visibility, things just being hidden in the family. This is swapping them out completely. All right. Number 9, bidirectional arrays. Once again, the answer is going to be nesting. It's the answer for a lot of things. Here we're going to take a chair family and load it into one that I'm calling chair width, but you could call it some other option here. You're arraying this across the x-axis from start to the end point with this end reference plane. And the number of chairs in this instance is set up by the width divided by the width of the chair. And I've got this round down section here, which helps prevent overlap in the chairs by not having rounding errors, by adding too many chairs because of a round up issue. All right, so I take this family and I load it into a layout family. And I select it after I've placed it. And I go and I find the width parameter of that family, of the nested family, and I tie it to the width family of the layout family. So now as one family's width is adjusted, so too will the others. Now I'm going to take that family again and I'm going to array it now vertically in the Y direction. Here I've got specific aisle lengths that I want, so I'm doing the second position instead of the end position. I can take that array value and give it the number of rows parameter, which is set up as the depth divided by that row depth that I need to hold on to. All right. So I also kept in the chairs per row calculation, so I could multiply the two together and get a total count in the layout. And now I can select the reference planes, pull it down, and get rid of rows, and pull the reference plane to the right or left, and add or subtract rows, or chairs per row, sorry. And I'm ready to load this into my project. And in the project, you'll see you've got these easy to use handles that make stretching and contracting so much easier. And there you have it. All right, we're on to number 10, adaptive components for footing steps. I know this is an advanced feature of Revit. You may not have used it before. It might be scary. Bear with me, all right? The first step is to create a new generic adaptive component, all right? We do that, and it's all going to be okay. You can always come back to this video later to work it out. In fact, you're going to have to, because I'm going to go fast because I'm running out of time. All right, step one, we make 3 points in a vertical plane, and then we make another point offset from point number 3. We connect all of these points using reference lines, and then we place a point on the long reference line, and we select that point so it's hosted on that reference line, and we change the measurement type to be a normalized curve parameter. By doing that, it creates the normalized curve parameter right below it, and we're able to map that parameter's value to a parameter we're going to call control run, so that we can create a formula that controls the run versus rise of this footing. Remember this moment, this parameter, normalized curve parameter, and you'll see later on how useful it is. All right, so we connect this point, this new point, with points 2 and 3, and we select them and hit the Create Form button up top to create the mask of the footing step. We select the extruded face and parameterize its positive offset value to be the distance that we're going to tie to a parameter we're calling width. All right, so once that is all set up, there's a few more parameters we have to make to match this: rise, run, original segment length, footing width. So you do all those, and then you add some additional parameters that are going to be controlled by formulas related to the reporting parameters. So this is a spot where you'll pause the video, you'll do all the work, and you'll come back to it. And once you've done all of these things, you're going to have this terrific component that you can come in and place. And I'm going to click on the end point of this footing, the near point, the depth, and the width, and it forms the footing step exactly how I need it. I'll do one backwards, and you will see something. It does create the footing backwards, which is why we created this parameter called flip. Just check that, it flips it around for you. Now, what's interesting about this, I'm just going to join the geometry to get rid of the seams, but what's interesting about this is because the adaptive component is tied to points on the footing, and the footing is created directly from the wall it's hosted on, is the walls shift and move around, get longer or shorter, the footings automatically update, and these footing steps will too. So you see that. Now, back to that control run thing of the formula we set here. When we say point to point, it moves that endpoint of the triangle to the end of the line. It slides it on down versus a 2-to-1 ratio. So if that's the better configuration for your footing step, you can easily click that and have that available to you.